All right, so what I'm going to do is I'm going to show you how to solve these problems in case you're at home and you want a review of how to solve problems that deal with day 4 problems. So we're looking at volume, and we can only do this at gases, and gases that are at what's called STP. That's standard temperature and pressure. You'll notice in all these problems they all say at STP. So as I always do, I'm first going to go ahead and look for my known. I know I have 16.8 liters of gas, and my gas is N2. My unknown is how many moles. Same procedure as always. I'm going to take my known, 16.8 liters of nitrogen gas, and I'm going to put that over 1. And if I have liters on the top, I'm going to need to have liters on the bottom. Well, I know from the notes that there are 22.4 liters of gas in 1 mole of gas. So my 22.4 liters is going to go on the bottom, and 1 mole will go on the top. My units are canceling out. I'm left with moles, and that's what I need to find, so I'm ready to go ahead and calculate this. So it's going to be 16.8 divided by 22.4. That leaves me in the calculator with an answer of 0.75. Now I have to go back and look at my known to find significant figures. There are 3 significant figures. So I'm going to need to have 3 significant figures in my answer. Decimal is present, so I'm going to start on the Pacific. Here's my first significant figure. Here's my second significant figure. I'm going to need to put a 0 so that I have 3 significant figures. So this answer will be 0.750 moles of nitrogen gas. Let's go ahead and do number 3. How many moles of carbon dioxide gas, or CO2, are there in 2.94 liters of this gas at STP? Mole my known is 2.94 liters of CO2. My unknown is how many moles. My known over 1. I have liters on the top, so I'm going to need to have liters on the bottom. There are 22.4 liters in 1 mole of gas. My liters are canceling out, so I'm left with moles, so I'm ready to calculate my answer. And that's going to be 2.94 divided by 22.4. And the number in the calculator is 0.13125. I'm going to need to have 3 significant figures in my answer, so I'm going to need to round this answer to 0.131 moles of CO2. And there's my final answer. Let's do number 5. If I can find number 5. All right, well, I don't have the 5 on this worksheet, but I've got it here in front of me, so I'm just going to kind of write down the question. It says, how many moles of xenon gas would occupy 3.78 liters at STP? So my known is there a 37.8 liters, and my gas I'm dealing with is xenon. My unknown is I'm asked to calculate how many moles. And again, this is question number 5. So I'm going to start with my known, 37.8 liters of xenon gas over 1 times, I've got liters on the top, so I'm going to need liters on the bottom. There are 22.4 liters in 1 mole. Ready to do my calculation. It's going to be 37.8 divided by 22.4. I know right off the top of my head that it's going to be 1 point something because I can tell that I've got more in my question than what a whole mole would take up. So I'm expecting an answer that'll be greater than 1 for sure. My calculator answer is 1.6875. I'm going to need to have 1, 2, 3 significant figures. So my answer will be 1.68, but it's followed by a 7. So I need to round that to 1.69, and that's going to be moles of xenon gas. Will be my final answer. Question number 7 says, what's the mass of 2.23 times 10 to the 23rd atoms of sulfur? So this is starting to add back in some mass problems. So my known is that I've got 2.23 times 10 to the 23rd atoms of sulfur. My unknown for question 7 is what is the mass? Well, mass is a weight, so I'm going to need to have my answer in grams. So I'm going to take my known, 2.23 times 10 to the 23rd atoms of sulfur over 1. I'm dealing with atoms in the top, so I'm going to need to have atoms at the bottom. Well, that's a number of atoms, so I'm going to need to use 6.02 times 10 to the 23rd atoms are in 1 mole. My units are canceling off. The number of atoms cancels off. I'm left with moles. I'm looking for mass in grams, so I'm not ready to stop here, so I'm going to put 1 mole on the bottom. And now I'm going to need to calculate what is the weight of sulfur. So I look on my periodic table, and I find that sulfur weighs 32.06 grams per mole. So 1 mole weighs 32.06 grams. These units are canceling off. I'm left with grams, which is what I need in my answer, and so I'm ready to calculate it. And it'll be 2.23 times 10 to the 23rd, in parentheses, times 32.06, and this is going to be 6.02 times 10 to the 23rd, in parentheses. And that'll give me an answer. The answer in my calculator when I do this, I get 11.8764, and I'm going to stop there. Need to know my number of significant figures. There are 1, 2, 3 significant figures, so I'm going to need to have 3 significant figures in my answer. So that'll make the answer 11.9, and that's going to be grams of sulfur. Because now I've got my 3 significant figures. All right, so now let's do number 9. Give myself a little room here. Number 9. Number 9 says, what is the volume of 8.7 times 10 to the 23rd molecules of chlorine gas? So my known is that I got 8.7 times 10 to the 23rd, and that's going to be molecules of chlorine gas. My unknown is I need to know what is the volume. Well, volume is going to be measured in liters. So that's the unit that I'm going to need at the end of this. So here's my known. Over 1. I have molecules on the top, so I'm going to need molecules on the bottom. There are 6.02 times 10 to the 23rd molecules in 1 mole. Molecules is canceling off. I need my answer in liters, so I'm not done yet. I have 1 mole on the top, so I need 1 mole on the bottom. In 1 mole, there are 22.4 liters. And now I'm ready to do my calculations, and that's going to be 8.7 times 10 to the 23rd, in parentheses, times 22.4 divided by 6.02 times 10 to the 23rd. This will equal a calculator answer of 32.372. I need to have 2 significant figures. So when I'm doing 2 significant figures, here's my first one, my second one, followed by a 3. So my final answer is going to be 32. And that's going to be 32 liters of chlorine gas, Cl2. And there's my final answer. So if you're practicing, I'm going to go ahead and give you the answers for the even-numbered problems so you can check your work. Number 2, the correct answer is 50.4 liters. For number 4, the correct answer is 9.74 liters hydrogen gas. Number 6 is 59.0 grams SO2. Number 8 is 1.47 times 10 to the 20, I can read that, 21st molecules. Number 10, the correct answer is 84.9 grams. And there's your answers. So if you're checking your work and working ahead to practice for the quiz, those are the correct answers.